Welcome everyone. This is a demo of Beeswax on HUE, Hadoop User Experience, which is a web-based user interface for Hadoop. This is what it looks like when you connect to it from a web browser. HUE is an open source project that's included in Cloudera's distribution for Hadoop, CDH, which you can download from Cloudera's website. HUE is a platform, comes with a suite of applications. User admin lets the administrator manage HUE users. Job designer and job browser lets the user create and manage ML jobs. The file browser allows the user to view HDFS, upload files, edit files, and so on. Today we're going to talk about Beeswax, which is a Hive UI. Hive, well, to put it simply, is a database layer built on top of HDFS that supports SQL-like queries. When we talk about database, first we look at tables. We have the 3 tables installed in this instance of HUE. We're going to add to it some examples, and you may want to play with the sample data that comes with Beeswax after you install Beeswax. Sample data are simply 2 tables and a few canned queries, the sample queries. That shows you how to play with Beeswax. Sample data, we click on it, brings us to this table view. It is simply some employment statistics of 2007-2008. On the left hand side, we can import more data, we can drop the table. View file location pops up the file browser, which shows the actual location where the data is stored in HDFS. This kind of cross-app linking is very nice with HUE. The Browse Data button shows the actual data from the table, and all of it. You can click Next to page through it. Behind the scene, it's executing a select star on our behalf, and here is the log from the select star. Pagination brings the next batch of data, and so on. There are 2 ways to create tables through a wizard in Beeswax. Create from file and create manually. We'll show you both of them. Create manually guides you through a sequence of steps that fills in all the parameters to create a table. We're just going to create a dummy table. As we walk through, you notice that there are lots of help tags and hints explaining what the fields do and how to use them. Finally, we create the columns. We're just going to call it foo and bar. You can also create partition columns. In this case, we execute. This is not executing the actual query yet. This is a preview of what's going to happen. We can further customize this create statement, but we are just going to run this, and a new table is created. The demo dummy table, it's empty of course, with columns foo and bar. We can import data. Just pick a location in HDFS, enter it, and hit enter. The other way to create a table is from an actual data file that you have, assuming that this is the format of the table that you want. I'm going to create a table called access log that stores actual access log file from HUE. I uploaded the access log in a gzip format to HDFS. It's smart enough to understand the gzip format and automatically decompress it for me. It's also smart enough to guess the delimiter for me. In this case, it's tabs, and that's correct. If it's not correct, you can say no and preview what it's going to look like if you select a different delimiter. Space is clearly wrong. And finally, we define the columns against the actual sample data from the file that we specified. We have timestamp here, the log level, the IP address, the user who's connecting, and the actual log message. When we hit finish creating tables, it creates the table and load the data for us at the same time. Now let's run some query. In the query editor, you can type in the query and then execute it. Suppose I want to find out access frequency. The explain button shows the Hive query plan of this query. Looks fine. And we execute it. Executing the query would actually spawn MapReduce jobs. There is a new job running. Clicking on it brings us the job browser. In the job browser, we can actually drill down to view all the tasks. Each attempt. Look at the metadata, look at the counter, and even go to the log message of the MapReduce task itself. And this is sometimes useful when you're debugging, trying to figuring out what Hive is doing behind the scene. We have the results back, the access count and username. Note that this is an unsafe query. In the history page, we are showing that we have an unsafe query, and the query is exactly the one that we just executed. We can always click back on the results button and show the results of the query that we executed. This is really nice, and it's very hard to do on the Hive command line. In the results page, another thing to note is that you can download it as CSV and Excel file. You can also save it as a new table in Hive or HDFS directory location. Say we create it as a temp table in Hive. When we hit save, note that a new temp table is created. Going into the temp table is exactly the query results that we expect. Now, let's modify this query and keep working on it. This is an unsafe query. To give it a name, we go save as and type in a name. Now it appears in the My Queries tab, User Frequency. Let's explore some of the advanced features on the left-hand side. You can show and hide the advanced panel. Hive settings lets you enter any Hive setting to run alongside with the query. Sometimes you may want to do a sort by and specify the MapReduce task to be 1. Sometimes you would want user-defined functions, and you can upload a jar file in the file resources to attach to this query. Parameterization allows you to enter parameters into the query. Actually, we still need the group by. When we run the query, it is going to prompt you to enter the username. In this case, I enter myself. Note that the username is substituted into the query itself. Again, we look at history. This query is running. It is an unsafe query because we haven't saved it since we modify it. But we can totally go back to this query and do a save as. Say user frequency by user. Another thing I forgot to mention is the email notification, which you can specify, you can check it, and you'll get an email when a query completes, useful for long-running queries. Save queries and history lets you look at your own save queries as well as other people's save queries. This is useful for sharing queries. You cannot modify other people's query, but you can clone them. And now you have a job loss copy query in your own query page. The last thing I want to point out is the Settings tab. It lets you view all the settings in Hive, and it's also useful for debugging. Well, I've shown you Beeswax, and hopefully you get a taste of the rich user interaction that's possible in HUE as well. Thank you for your time. Bye.